Swayam Prabha. Digital India. Educated India.
Very good morning, good evening and good afternoon to all my students. So, wherever in whichever part of India you are, hope you are enjoying this course, and I am Raghunandan Sengupta, a faculty member in the IME department at IIT Kanpur, India. So, the course, as you know, is basically on project management, and for the last 2 lectures, this is the 27th lecture of half an hour each. So, you are discussing that how to find out the interest rate given the 0 rates and corresponding values. So, if you refer to the 26th lecture, so the interest rate for half a year, which is 0.5 of a year, then 1 year, 1 that is 1.0 year, 1.5 years, 2 years were given correspondingly, and based on that we are trying to calculate. And also it is mentioned that if you see this 322nd slide, so it was mentioned that how the payments were being done, whether they are being paid in each quarter, whether they were being paid in the semi-annual basis, annual basis and corresponding values. So, going for the second set of calculations. So, now if you see the table, so the face value of so called payments is 100 and 94.9 was the actual value which you would be getting and earned corresponding to the aspect that there would be 6-month payment happening 2 times in a year. So, if you see the bullet points, it goes exactly like this. An amount of 5.1, which is the difference between 100 and 94.9 can be earned. So, that amount can be earned based on what value? So, that value is 94.9. So, if I want to find out so called ratio or interest rate, it would be 5.1 divided by 94.9. Now, the next question would be, is it being paid on an annual basis? The answer is no, because you will have such 2 payments happening in 1 year. So, the next bullet point is exactly what it says. The 6-month rate is, you have to find it out, it will be twice into this amount of 5.1 divided by 94.9, which comes out to be 10.4748. Now, this is being semi-annual compounding. So, if it is semi-annual compounding, you have to find out the continuous compounding rate using the formula which we have discussed in the last class. I have just mentioned that slide. So, if somebody is interested, they can check any basics finance book to understand how these calculations are done. Based on 10.748, which is the semi-annual compounding rate, we find out the continuous compounding rate is 10.469 percentage. For the third set of values which is given in that table, so you earned 10 rupees or $10 whatever it is, based on the fact that for a face value of 100, 90 was basically the value which was earned. So, 10 can be earned on a value of 90, the time duration is 1 year, which means the 12-month interest rate would be, because there is only one payment happening in a 1 year. So, it will be 1 multiplied by the ratio of what is the amount you are getting divided by so called input price or what is the actual value you are investing. So, that is 10 by 90. So, that comes out to be, the ratio comes out to be 11.111. Interest rate is being calculated on an annual compounding basis. So, if you convert into a continuous compounding basis, the value comes out to be 10.536. So, we have found out the continuous compounding interest rate for 1/4 of a year, for half a year, for 1 year. So, these values have been calculated, based on that we will basically now proceed. So, now if you see, you need to calculate the 1.5 year, that is 1.5 years interest rate. Now, the question, if you check the table, I am not going to go back to the table, you can refer back to the table in your last class, which was the 26th class. So, it says that 8 rupees, $8, 8 euros, whatever was there was being paid on an 6-month basis. So, which means that I will get, or the person who is going into the investment would get 8 divided by 2 per 6 months, but this 6 months has to be calculated based on the fact that what is the present value of that amount which accrues to me as of now. So, if you see the first value on this slide, which is the 324th slide. So, as I mentioned, 8 by 2 is the amount. So, when it is being paid, you should ask your question. So, it is being paid after 6 months as of today. So, now the next question would be, what is the amount of that value as of now? So, you have to basically find out the time value of money, which means it is continuous compounded, which you have just found out, which was 10.469. You basically multiply is with e to the power minus, because as you come more nearer to time t is equal to 0, the value will decrease. So, it is e to the power minus 0.10469, which is the interest rate, multiplied by half, which is 0.5 is the time period. So, based on that you find out the first term, which is the actual value for the so called 4 rupees which you would have got or which you get after 6 months. So, the next calculation would be based on the fact that you will get another 8 rupees, $8, whatever it is, divided by 2, obviously, sorry, my mistake, because it is being paid 2 times in a year. So, this 4 rupees would be obtained after another 1 year, but in this 1 year time period the continuous compounding rate is different. What is that? That is 10.536. So, again you multiply e to the power minus 0.10536 into 1, because now the time period is 1 year. So, this value which you get is actually the value which you would have got now, provided no 4 rupees was paid after 1 year. Now, the last term which you have to find out on the equality side is, given the fact that the value was 100 rupees. So, that you will get back plus the interest rate. So, what is the interest rate? Again the answer is 8 by 2, because it is being paid after each 6 months. So, for the 1.5 years time period, first 6 months this value you have got, next 6 months this is the value which you have got. So, out of after 1.5 years, 1.5 years, the interest rate is this plus the principal amount, both are being calculated based on the interest rate which is continuous compounding for a 1.5 year period. So, 100 is known to you, 8 by 2 is known to you. If you see the e to the power terms, so minus r, why r? Because this is the continuous compounding interest rate based on the fact that is true for a time period at 1.5 years, because that 1.5 years is coming here. So, based on the fact that the actual value which you have got would have obtained is 96 as per the values in the tables. So, when you equate that, find out r value, it comes out to be 10.681. So, now what you have got is this value which is 10.469 is the continuous compounding interest rate for half a year, 10.536 is the continuous compounding interest rate for 1 year, and 10.681 is the continuous compounding interest rate for 1.5 year. Now, I need to find out the continuous compounding interest rate for 2 year period. So, what I do is that I again go back to the calculation, check what is the interest rate being paid. Now, it is 12 rupees, 12 euros, whatever it is, on a half a yearly basis. So, the interest rates are being paid, if you note down carefully, it is after 6 months, after 1 year, after 1.5 year, plus after 2 years also, but at the end of the 2 years, apart from the interest rate, you will get the so called principal amount which was 100. So, let us do all the same set of calculations as we have done in the previous slide, which was 324th slide. So, the 325th slide are exactly the same, based on the fact the concept is what we are trying to follow, is based on the same set of formulas. So, this 12 by 2, which is 3, which is appearing 4 number of times. The first one is after 6 months, I am repeating it, please bear with me. The second 12 by 2 is after 1 year, third 12 by 2 is after 1.5 years, and fourth 12 by 2 is after 2 years. So, now if I check the interest rate, they are basically being obtained from the table as well as from the calculation which we have just finished in the 324th slide. So, 10.469 is the continuous compounding interest rate for 6 months, 10.536 is the continuous compounding interest rate for 1 year, and 10.681 is the continuous compounding interest rate for 1.5 years. So, now we do not know the continuous compounding interest rate for 2 years, we considered it as R, equate it to the value of 101.6 as given in the table, solve this equation, get the value of R, the R value comes out to be 10.808 continuous compounding interest rate for a 2-year period. Now, if you note down the values in the table, so the first column is the maturity in years. So, they are the 0 interest, we want to find out the 0 interest rate continuous compounding for that time period. So, again I am repeating, so this time period are such that you start your clock ticking at t is equal to 0, stop it at t is equal to 0.25, and there the continuous compounding interest rate is given as the first value in the second column, which is 10.127. So, in between there are no payments. Then if I go to the second set of values, second row, it is for a half a year it is 10.469, for a 1 year it is 10.536, which is the third row, and corresponding to the values in the fourth and the fifth row, they are for a 1.5 year it is 10.681, for 2 years, and we just calculated in the 325th slide, it is 10.808. So, we have got the 0 rate continuous compounding. If you want to find out the compounding or the simple interest or whatever it is for those time periods, you can do that using the simple formula which we have shown, that how to convert any compounding interest rate to the continuous compounding interest rate and vice versa. So, I plot this values with maturity along the x axis and the interest rate being plotted on the y axis. So, remember this is the interest rate based on the fact is the 0 interest rate, intermittent payments for the projects are not there. So, if I plot the value, and in a very simplistic notion, what I can do and why it is important is that, say for example, I want to find out what is the continuous compounding interest rate for the project, and I want to have some feel that what should be the actual value. So, if you go along the x axis, mark a value 1.25 years, go vertically up, where it cuts that graph 0 curve, go again to the left on a horizontal direction, and the value which you find out can be used as a theoretical value based on which you can do some calculations and find out that what would be the project yield, project return, and so on and so forth. If I want to find it out, say for example, for 2.25 years, again I would go vertically up, stop at the point where it basically marks along this curve, and then go horizontally onto the left. I will come to one value along the y axis, which is the 0 interest rate, use that value for my calculations. So, if my values when I do my calculations are very close, and if I have more number of values, then trying to basically fit a better curve in place of this set of straight lines which I have for this curve for the 0 interest rate would be much more useful in trying to do our calculation. So, one word which I did miss, that even though I thought it is not important, but I will just try to mention that, even, and that is nothing to do with your concept which you are trying to cover for the project management part, is that if you remember in the 326th, 325th and those previous slides, the word which was there on the top of the slide was bootstrapping. Bootstrapping means basically means that you are wearing very high heeled boots till your knee, and as you basically tie the knot, you come up from the lowest level and then keep tying it up till you are able to secure the boot in your legs. So, it means that as you go up and do the calculation, some iterative methods have to be used in order to find out the concept that how you can find out the interest rate, and bootstrapping is just for the interest of the candidates and the students is very heavily used in statistics and simulations, and there are different concepts of bootstrapping which can be used on a theoretical framework to find out very good results. That is from the statistics point of view, just I wanted to mention that. Now, I want to find out the forward rate. So, given all the calculations which we have done are for the 0th rate, my main intention is to find out the forward rate. So, this is the interest rate implied by the current 0 rate for a specific future time between two 0 interest rates. So, let me draw a simple diagram and I am sure it will be clear to all the candidates. Consider my t 0 is this point which I will mark. Consider this is t is equal to t 1 and this is t is equal to t 2. So, I have the 0 interest rate from 0 to t 1, also I have the 0 interest rate from 0 to t 2 and correspondingly all the 0 rates are there. So, what is of major interest to me and I want to find out is that what is the interest rate which is applicable if I start my clock at t is equal to t 1 till the time t is equal to t 2. So, if I have some investment happening for the project between that time of t 1 to t 2, it would be essential on my part to have a note that what can be the actual or probable values of the interest rate happening between that time. So, that I can do my calculation and understand what is the overall cost implication for the project in a much practical sense. So, this is what we want to do. Given the 0 interest rate, I want to find out the forward rates. Now, in this calculation I am again showing the table. So, this table basically the first columns are the years, years are again discrete, they can be in decimal also, that does not matter. The 0 interest rates are given starting from, which is the second column, starting from 10.0 to 11.1, which is for year 1 till year 5 respectively, and the forward interest rates are given here, and we will now try to basically discuss the concept of calculation of how they are found out. So, the forward rate for if you see the second row which is for year 2, the last value is 11. So, this is I am marking here 11. If you see the third row, the last value in the third row is 11.4. Then if you go down bottom and go down along the third column, the next value is 11.6, the next value is 11.5. So, this is of interest to us how we find it out. So, suppose the 0 interest rates for maturities of T 1 and T 2, if you remember in the 328 slide I mentioned T 1 and T 2. So, there T 1 and T 2 were T with small t's. So, that hardly matters, because if whether you are using capital T or small t, the actual concept should be made clear to the students in the best possible manner. So, suppose the 0 interest rate of maturities T 1 and T 2 are R 1 and R 2 respectively, and both rates are continuously compounded. So, this has been highlighted because I want to mention that if you are trying to calculate the forward rate based on the fact that it should be continuously compounded, you use the 0 rate and based on the fact that they have been continuously compounded. If you are using the simple interest rate, use it for both the 0 rate and calculate the forward rate based on the fact that you want to find out the simple interest rate. So, try to do the calculation on the same datum and then changing it from simple interest to compounding interest or compounding to continuous compounding interest, that hardly matters. So, now the forward interest rate would be found out using the fact it is equal to R 2 into T 2 minus R 1 into T 1 divided by in the bracket T 2 minus T 1. So, that can be derived very easily. I am not going to go into the derivations or simple concept how they are actually used to derive. So, okay. So, based on the fact that the forward rates are R 2 minus into T 2 minus R 1 into T 1 divided by T 2 minus T 1, you can find out all the values in the third column for the table just shown. So, the table was basically the 329th slide, where in the first column you have the years, the second column you have the 0 interest rate, and the third column you have the forward rate. So, those forward rates can be calculated considering the formula and the year and the 0 interest rate. Now, I will just discuss in a very qualitative sense the sloping of the different curves when the yield curve is upward sloping or the yield curve is downward sloping. So, if you remember, we did discuss and found out the project yield or the par yield, then we found out the 0 interest rate for the projects, and then we consider the forward interest rate. So, if the par yield is increasing or if the forward rate is increasing and the dy dx of any of these values is increasing, then the sequence of the, again without going to the theoretical proofs, I would just want to mention the sequence of the forward rate, 0 rate and the par yield are as shown here. Here the orange line is for the forward rate, blue line is basically for the 0 rate and the green one is for the par yield. And for the projects, if it is downward sloping, that if the dy dx are negative, then the graph will look exactly the opposite, where the forward rate, which is the red one, would go in the bottom, then you have the 0 rate and then you have the par yield. So, these are just for the concept that as you are using these different type of concepts of interest rate or the IRRs or the net present value, or say for example, the fluctuating interest rate, the fixed interest rate, the 0th rate, the forward rate. So, those can be utilized in a very intelligent way to find out that what is the net present value of a project, or whether it is positive or negative depending on the outflows and the inflows, so that you can make a judicious decision whether that project can be taken forward to its next step of logical conclusion. So, now I want to find out the instantaneous rate. So, if you remember, the formula for trying to find out the forward rate was what? It was R2 into T2 minus R1 into T1 divided by, in the bracket it was T2 minus T1. So, if you do the limiting concept there and try to utilize that, the value comes out to be as I am circling, which means the instantaneous forward rate for a maturity T is the forward rate that applies for a very short duration of time starting at time t. So, this R which you have is basically the year rate or the t year rate which is given here, and this del R del t is the rate of change of that interest rate function with time, and that multiplied by the time duration of time which you are going to take. If you utilize this formula, you will be able to find out using simple concept of bootstrapping to find out each time period forward rate given the value of the 0 rate is known to you, and based on that you can find out at any instant what is the project yield, what is the project value, what is the project's IRR, and so on and so forth values, based on which you can take a judicious decision about the project. Now, I will just come to the concept of forward rate agreement. Even though it is not immediately applicable for the projects, but forward rate agreements would give you a picture that how they can be utilized to at least judge whether the project is actually feasible or not from the financial point of view. So, forward rate agreement is a forward rate contract where the parties agree that a certain interest rate will apply to a certain principal during a specified future period. So, if your forward rate is very high or very low, it will have some consequence on based on the fact that what is the amount of money you can borrow or what is the amount of money you can invest for that project, based on which you can take a decision and compare projects such that the expected value of the project is high or the variance of the project is low or any other values, such that the project implementation can be done thinking about the overall scope of the project which is there, which is the deliverables, how the social impact would be, what is the financial implications of the project, what is the overall effect of that project on the organizational variables which you want to consider, and all these values. Now, we will come to the duration of the payback time. So, very simply duration and payback time means the time starting from today, which is t is equal to 0 till some time, such that I am able to get back my overall investment and make the money in such a way that whatever investment I have done is returned back to me. So, consider the IRR. IRR, if you remember, is the internal rate of return, was that rate such that the net present value basically becomes 0. So, what I want to find out is the duration such that depending on whatever the inflows and outflows are, I am able to get back within the time frame the overall amount of money which has been invested by me, considering outflows and inflows in a cumulative sense. So, it means the duration, the payback time of a project is a some sort of measure that how long on an average that one has to wait before receiving the cash payments from the project. So, shorter the duration means faster I am able to get back the money, longer the duration is that it will take a much longer time such that that project may not be at all feasible, because if it takes a long time to get back the money which I have invested, it means that it is not worthwhile to take a decision to invest in that project. Hence, a project paying 0 payments that matures in n years has a duration of n years. So, I will discuss that within the formula within another 1 minute, which would be coming in the 336th slide. And the last point which is there in the 335th slide basically means that, however, we can say that the project paying some returns maturing in n years have a duration less than n, which means that if I am getting some money before the 2 years for which the duration is there, then means that I am able to retrieve my money from that project in a much faster duration. So, the duration would be less than 2 years. So, obviously, that would depend on what is the interest rate, what is the payment period happening, what is the total amount of payment happening at what duration of time. So, they would be duration is basically a so called average value, but that average value is weighted depending on the inflow and outflow and the time duration which you have. So, how it is done? Let us see. Now, let us consider this formula which is given in the 336th slide. As I mentioned, duration of a project can be provided that you have the cash flows are given, positive or negative, that is immaterial. If CI is positive, it will be taken as a positive sense, it is negative, it will be taken in a negative sense. So, the cash flows are given as CIs at time period Ti. So, this CI may be any random fluctuation of returns or random fluctuation of payments, whatever it is, and this time period which you have need not be of equal intervals. So, it can be either a quarter of a year, then it can be 3/4 of a year, it can be 1.5 of a year, it can be 5 years, whatever it is, it does not matter. So, let us concentrate on the terms which is outside the bracket, which is Ti, and the term which is on in the numerator of the terms which is inside the bracket. So, the inside the bracket, if you see, it is Ci multiplied by e to the power minus y Ti. So, this y value is the yield, which is the continuous compounding yield which you have already discussed in the last class. So, now when I basically sum up C1 into e to the power y minus, obviously minus y into T1 plus C2 into e to the power minus y T2, if you add them up, this is the total value of the inputs or outputs which is happening, and I am trying to find out what is the net present value of that amount. Now, what I want to do is that I want to find out the duration of the payback period such that in each value of B which I have, B is the time duration which I need to find out. So, if B is the price of the project and Y is the yield, as I mentioned. Now, if you multiply the overall amount which is coming at time to 0 multiplied by T, it basically means some sort of averaging which you are doing, based on which you want to find out the average time, that the value would have a so called 0 net worth to me at that point of time. So, if you see the terms inside the bracket whatever your terms is basically those are rupees to rupees. So, in the numerator you have rupees, in the denominator you have also rupees. So, that cancels each other. Outside the bracket is T. So, I am able to find out the weighted sum of the times, as that the weights would be coming up from the fact that is the net present value divided by the value B of the project. So, further it is or closer it is to my time period T0, it will basically the weights will change accordingly. So, I find out the sum of those weighted sum of those times, and based on that I say that this is my time period weighted sum, such that I am assured that my overall return has taken place to the exact amount. Now, this if you note the term in the bracket is the ratio of the present value of the payment of the project at the time t1 to the project price and cost, and if I am able to find out the dy dx of that, it comes out to be del b, that is the rate of change of b divided by b, which is the price of the project, equal to negative of d, which is the duration, into del y, which is the interest rate which you have. So, I would not go into the details of how these things are derived, but slowly solve problems and discuss that later on. So, with this I will end the 27th class and then start of the 28th related to the PERT problem. Have a nice day, and for any queries as mentioned, please get in touch with the forum. Thank you very much.